Hi, hi, Limor. Thank you for your time. Sorry, I'm Charlie from Oregon City in Oregon, and I was just wondering, given the Adafruit is heavily invested in open source hardware and all that, I'm just curious. What are your thoughts on like the future of RISC-V for CPUs?
Yeah, that's a good question. It's funny, actually. I did a talk with Satya Nadella, who is the CEO of Microsoft. Like I did a presentation, and he asked me the same question. So I'm not saying you're as smart as Satya Nadella, but like you kind of are. And he thinks a lot about technology, and that's an interesting question. So RISC-V is, an open core designed at Berkeley. It's gone through, multiple revisions. In fact, it turns out that one of the people who works for us worked on like RISC-1, like the first revision. He's like, oh wow, that that graduate school project actually like turned into a product. It's interesting because right now a lot of chips are based on like the ARM core, and you have to pay ARM a royalty for it. And you basically every ARM chip has the same core, same instruction set, except they add all these peripherals. So it's like this one's really good for radios, and this one's really good for data acquisition, and like this one's really good at like graphics display or whatever. Everyone's got their own peripherals, but the core is the same. But there's a couple things that I think have accelerated RISC-V. First off, there's a lot of times when you need to have an embedded processor, and it's like it just really needs to perform this one task and one task really well. And so, for example, a hard drive has, or an SSD drive has a microcontroller on it that performs the data caching, the reading, and all the things that you have to do. And historically, I think they used 8051 cores, and then I think they needed a little bit more speed and power, and so maybe they went to ARM cores. I actually don't know what chip they used, but eventually Western Digital, which is a massive maker of disk drives, said, I'm paraphrasing, I don't know exactly what they said, but I'm guessing they said, we're tired of paying ARM this royalty, so let's make a custom RISC-V chip that is designed just for hard drives, and they can add instructions that optimize for the kind of behaviors they need, because they need to make like one thing and they have to just duplicate it like 100 million times. And so they know after using chips for like 20 years what kind of instruction set they want. And so for that use case, RISC-V is extremely handy. Another use case that I'm seeing is RISC-V sub-processors. So I've actually seen this a couple of times now, where you have a main core that could be a Tensilica core, an ARM core, and that's because like the company knows it, and they have the IP for the core is already set up, and they're like, well, I don't want to mess with the thing that's working out because it takes years and years to develop a core. What they'll do is they'll glue an ARM, a RISC-V on there, and it'll be like a sub-processor. And so it could be used for low power, like the main processor would shut down for sleeping. Like if it's a wearable, if you're not looking at your watch, it goes to sleep. And then the RISC-V core, which is a very low power, small core, kind of just does the things like, oh, did somebody press a button? Or for, when you're talking to an assistive, like a voice assistant, and you say like, hey, Alexa or whatever, the RISC-V would recognize the wake word. And then it would be like, oh, hey, it's wake word time. Boot up the main processor to do the work. And then like the third case, which I'm kind of seeing, is RISC-V being used and glued on with machine learning peripherals. So people who want to do like TensorFlow Lite on microcontrollers. With ARM, it's been optimized a bit, and they've done a good job of getting the best performance you can out of a processor that was not designed for doing machine learning. But with RISC-V, people are like, oh, I'll just take this core and I'll just glue on all the stuff that you really need that makes TensorFlow run fast. So I'll make a chip that can basically be 10 times the speed for machine learning. It doesn't do other stuff as well, but it's really good for that. So those are the three cases I'm seeing RISC-V being used for.